Morning, everyone. So today, I want to share the stage with Blockheating to talk about cloud and efficiency. The question is it a waste of time to try to build an efficient cloud? So 3 points background about Sardina. We are a European cloud platform software company. We built a product called Sardina FishOS, which builds on OpenStack, Kubernetes, and Ceph. And we've been building sustainable cloud since 2014. The question about efficient clouds, does it matter? From a financial standpoint, from an ESG standpoint, does it matter? So, can enterprises really trade on reputation? Can enterprises be measured only on financial performance? Are they only measured on financial performance? And are capitalistic enterprises dinosaurs? And are regulations universally applied? Well, there's one thing that we can agree on. These are all complex questions. These questions, in turn, have an impact on whether efficient clouds matter or not. However, what's indisputable is that lower cost is good, yes? And we also know the higher revenues is good, yeah? Next, we know higher margin is good. And we also know that lower CO2 footprint is good, yes? Right. So let's focus on these few points. And FishOS, what we do is that we provide a cloud platform that addresses the full life cycle of cloud life cycle. Deploy, operate, and upgrade. And it's been validated on OCP. And today, I really want to focus on the 2 points, the 2 phases, the deploy phase and the operate phase. The deploy phase, what do you want as an operator? You want to bring up the system easily, quickly, minimal fuss, and you want to run the system efficiently and reliably once it gets into operate phase. Yeah? So let's look at the deploy phase. What we've done is that we bring up a first node. It's based on Ironic. So this is OpenStack Ironic. Deploy space operating system. And because the hardware is fairly limited in number of disks, so we have an LVM cache on the SSD for local storage on the spinning disks. And then from there on, it's really deploy the rest of the system with FishOS deploy as usual. And at that point, it's really no different than standard 19-inch servers. So what's the secret? Where's the magic? The magic is all shoved into this one single tool called FishOS Deployer, based on Ansible. And this is what allows us to deploy system easily, flexibly. And in our internal development, we do bring up teardown in a fully automated manner. Gone are the days when you need 3 months of consulting to deploy an OpenStack system. And included with this, you get a Ceph deployment as well. So the net result, you have a full-featured cloud platform including all the ops tools pre-integrated, pre-deployed at the end of the deployment process. So now let's look at how to operate the system. When you're operating a system, you have two key challenges, namely how to run the system efficiently and how to run the system reliably. On the efficiency part, let's look at a component. This is one of the parts within FishOS. It's called Workload Manager. What does it do? It takes live resource utilization across a whole facility, and it computes how to basically do high-dimensional jigsaw puzzle. Solves that problem, optimally pack the workloads, and does this continuously. And the objective is to minimize the number of servers to run the workload. And then, as a result, you minimize energy consumption. And by using the same data, what we also do is that we can place new VMs onto the right nodes at the right time. And a further subpart of Workload Manager is Power Manager. You can use Workload Manager in multiple different ways, whether to optimize the energy consumption or optimize the number of servers being up. Not always the same thing. And you can also look at optimizing the VMs that you can host at any point in time, or freeing up hardware to run VMs. And a Power Manager, what it does is it does the calculation on how to optimize energy consumption across the environment. And then you can turn on, turn off machines as needed. And we can also take into account the CO2 metrics. So this is a very simplistic diagram of what happens in Workload Manager. So track utilization, calculate optimal packing, and then move to rebalance, turn off servers if you're able to, turn them on if you need to, and then you repeat. And the bottom line here is that the energy not consumed, therefore, equals energy saved. Yeah? Therefore, equals money saved. Very simple. This is good for business. And next, we have the challenge of keeping the system up. So Health Manager is to address this objective of getting to more than just dead or alive. Now, if you look at traditional monitoring, what are we doing in traditional monitoring? The principle in traditional monitoring is that you probe, the endpoint responds, you say, great, it's alive. Next cycle, you probe again. It doesn't respond. Not quite sure what's going on. You probe 3 times, it's still not responding. At which point you say, right, let's declare death and call the operator. But by the time you do that, the system is already impacted. The experience of the service consumer is already impacted. This is bad for business. So what we want to do is that we want to understand that there's something not quite right in the system. The system is ill. And upon detecting that, we can take early action. This is very similar to how we treat human health, right? If we're simply redefining the levels of death, then perhaps we'll be burying a lot of sneezing people That is simply nonsensical. Yeah? And so the issue of running system reliably, you take log data, you take metrics data, goes through a decision engine powered by machine learning, and then from there, we classify, is it sick, is it healthy? And based on that, we can take action, and it repeats. So net result is that you get high reliability, which therefore translates to a better service consumer confidence, and therefore, it's good for business. And so, in total, what we do is that we take these components together, build a reliable cloud platform, build an efficient cloud platform running on OCP, and high efficiency translating to lower cost, high reliability translating to higher revenues, and overall, it's good for business. And the hardware has some interesting characteristics also. I'll leave that with Jeroen.
Thank you for that epic introduction. I think in cloud in general, turning off machines is considered the holy grail, which might still give some IT people quite some anxiety, but it's really nice to see in the metrics that machines are actually turned on and off. So yeah, I think that's really cool that it actually works and it actually saves power. So who am I? Who are we to stand here? I'm Jeroen Burks from Blockheating. We founded 5 years ago based on the principle of let's optimize the hardware infrastructure that we have to run cloud. So running decentralized, running water-cooled, reusing the waste heat, and providing a forecast in power and CO2 impact of that power. So we have one data center currently running. It's in Venlo, and it's built with custom water loops. So we put this data center right next to a tomato greenhouse. Holland is quite famous for their greenhouse culture. And in the Netherlands, there's about 3,500 hectares of greenhouse. And that's enough to recycle about 700 to 800 megawatts of energy in the summer. So the energy savings potential is huge, as long as you integrate it well with the cloud operating system. So we're running OCP v1. So that's, really, I would say, diehard OCP, no redfish, IPMI tool, and Sol sessions are your friend. And again, we are running a custom water loop that allows us to get to really high temperatures without the need for a heat pump. We started analyzing the system of a typical data center, and there you see that a heat pump is a constant factor of power consumption. If we can get rid of it by recycling the waste heat, then that's actually quite ideal. So as you can see, we are located like 5 meters away from the greenhouse, providing our hot water to that greenhouse. And we built a custom water loop in order to get higher end temperatures. A lot of cooling systems, direct chip cooling systems, have been made for maximum cooling. What you see is if you want to get maximum heat reuse, then you have a different cooling system. So we modified our cooling system for that, and it's been running now for 2 years. And on top of that, we're also providing a forecasting model, as mentioned. So mainly developed within EcoCube, a EU-funded project where we analyzed power data, but also server data, chip data, data center data, all in one homogeneous data set in order to make accurate allocations of how much is one machine contributing towards the total energy consumption, towards the total CO2 footprint that we're running, and towards the heat reuse that we are achieving. Of course, measuring PUE, REF, but I think the real interesting part is to provide the metrics from the grid towards, in the end, the cloud operator to make decisions on that and operate, to act on that. So for that, we have a 24-hour forecast, and what you actually see in the power pricing, at least in the Netherlands, that there's a really high correlation between the power pricing and the CO2 pricing. That has obviously something to do with the availability of renewable energy. At the moment that there's a lot of renewable energy available, then there is not so much need to turn on gas turbines, which has a big impact on the pricing. And it's a bit difficult to see, but in pricing, it would double, maybe go from 10 to 20 cents. But in CO2 levels, it can switch from 100 to 600 grams per kilowatt hour. So we hoped to share some preliminary results, yet, I don't think we are there yet. Maybe we should update that once the presentation goes live, that we can actually share what impact has been made by Sardina by running on these metrics. And with that, I think we can conclude the presentation.
And if you want to find out more, that's the QR code, and come talk to us. Don't worry, we don't bite. Any questions? Yes.
Sorry, can we have the question? Hello, there we go. Let me make sure that we capture this question on audio.
Yeah, welcome, thank you. I have a question regarding the workload monitor. So does it mean that you shift workloads also from one machine to another machine to save the power? So for instance, if I run a cluster in a large data center, I am smaller hyperscaler and have a lot of workloads from different customers. They are usually work not all at the same time. Mm-hmm. So do you also recognize that a workload is on that hardware, on that hardware, on that hardware, collected all together and put it on the same hardware to switch off the other two machines?
Correct. So okay. With OpenStack and the workloads running in VMs, key being workloads in VMs, what we can then do is that we can live migrate the workloads and optimally pack them, and we do that respecting the constraints that you may also place on the placements of the VMs. So if you may have affinity, anti-affinity rules, so those have to be respected, and so we look for those characters to figure out how to optimally pack. Now, sometimes you do have VMs that are more difficult to migrate. So, for example, the VMs that may have very high I/O, VMs that may have a lot of updates and memory pages. So those, they are treated as anchor VMs in our system. And being anchor VMs, we don't migrate those away, we migrate others to them. Okay? And then by doing that, we can optimize the overall placement. Now, you may have situations that subsequently that the workload pattern changes. And we detect that, and next rebalancing cycle, we recompute. And then we have a new layout plan and execute the layout plan by live migrating again. Okay? Great, thank you. So if there are no other questions, then thank you very much. Yes, please. So the question is whether we discover potential hardware failure in the health monitoring system. So when you look at our health engine from the perspective of the health engine doesn't understand whether it's hardware or software. And in fact, it doesn't care. It deals with two types of data, log data and metrics data, regardless of what the source may be. So with that, it tries to understand whether that is a picture of health or a picture of illness. So now let's look at an analogous situation in relation to human health. So now you don't just want to know if your patients are dead or alive. You want to know the patients who are alive but may be ill. Yeah? So what you can then do is that you put the patients through a imaging system. Let's, for the sake of simplicity, say you put them through an X-ray machine, okay? And out comes on the other end, you get pictures, X-ray images, yeah? So you take these pictures, you put them now through a classifier. The classifier detects whether there's anything abnormal. And if there's something abnormal, it flags it, and the doctor is alerted. The professional is alerted. So at the point of classification, does it need to understand whether it's a picture of the patient's chest or combination of head and foot? It doesn't need to. It's looking for patterns, looking for abnormality. And so in that way, we handle hardware, software equally the same.
But not really predictive then. So sometimes you don't know that you're ill, and even the machine does not see that you're ill, but there are signs that you will become ill maybe in a few days.
So the question is the characteristics of illness being reflected? If there are telltale signs of this being something not quite right, we'll detect it. So if there are absolutely no telltale signs of it, then we can't do anything about it. Yeah, okay?
All right, I think that's all the time we have here now. We've got to move on to the next speaker. So I really encourage everyone to check out what Sardina and Blockheating are doing. Some fantastic members of OCP doing some great stuff. Thank you very much, Kenneth.
Thank you, everyone.